Okay, hopefully this is working. Hello. Yes, I believe this is working. Yeah. Say hello in the chat if this is on, please. I am not sure if we're public or not. There's some people joining, so not good. Yeah, I have no idea how this stuff works. So I'll mute me. I am currently finishing off a biology poster in the middle of, and then I will get to maths stuff. So yeah, if you're here, I have to say hi in the chat. I think I can. Hello everyone. Oh, there we go. Okay, things are starting to work. So I'm going to finish this very quickly. There's not much left to do. Yeah. Yep. After this, I move on to maths, and then because I have a tracking test tomorrow and kind of want to get work done, but yeah, not do that. So, this is the thing that my camera is on is really awkwardly placed. I can see if I can move the chair down, work underneath it. I'm also wearing a onesie because I'm cold and tired. Yeah. Yeah, if you're here, please talk to me. I can see all the comments and will reply live. So yeah, please do that. It'll help me feel like I'm not alone as well. I know that there are definitely 6 people watching this right now. I can see the concurrent viewer number. So here, say hi if you're here. I can check analytics and can I see who? Oh, I don't think I can see who's viewing. So please interact. Can you hear me? That is the question. Actually. Oh, how do we know? Okay, yes, this is working. So I want to check. I might be able to hear myself. Okay, yes, it's fine. Hi, Zara. How do we know if the proteins are globular? As far as I'm aware, usually if they have tertiary or quaternary structure, they will be globular because they fold up to form more circular 3D structures. As far as I know, that is how that works. Yeah. This is my last point. I'm not doing my prion poster right now, and then I'll get that stuff, and then we'll start on maths because that is the test for it. This is the art we love maths, don't we? Okay. Lewis Groves. Yeah, Lewis, your comment is held for review. The answer is, of course. Yes, I agree. Okay, this is biology done. That's my biology done. I just wanted to get that done before I started. Now to rip this out and then grab some maths work. I think I'll probably start with surds because I can do surds, but not all the time. For biology, can I get there? If you don't understand me, I'm probably speaking Denglish to myself. That is that. Then Wilson, must see where you're at. Must have got right here. Right. Actually, yeah, I'll use the book anytime. Clean page, and then I will grab my math supplies. I have a calculator. I will need whiteboard pens and stuff like that. Maths books. Let me see. I'm currently grabbing my portable whiteboard. Let me see. Maths textbooks. I have quite a few maths textbooks at home. So, nope, that is not a good one. It's kind of red. Not great. This one's slightly better. Okay, now that is sorted. Right. Let's try and stick this down to the page so that math is as nice as possible. Okay. So yes, right, people in my maths class, if you're watching, maths questions, because I have no idea. Anyone else? Talking is permitted in the comments. Where is C1? That is this. Okay. I know I have another ordinary maths textbook somewhere, but I can't find it, so I'm using this one. At the minute, where is or are surds? Because they are important. Getting curves. Do we have surds in this textbook? Are there surds? Surds. Yeah, by the way, I'm slightly sick. Quadratic inequalities, yeah. Okay, right. I'll do quadratic inequalities first. Because they are definitely on the test tomorrow. Are these surds? Okay, then algebra functions at the start. Right, surds will come later. Quadratic functions. Oh yeah, I'm not. I should probably be doing this in front of the camera. Quadratic interesting. Quadratic equations of inequalities. Are there any things here? Your quadratic inequalities, aren't you? Which ones are quadratic? None of them look quadratic. Nope. Do we have an extra? Yes, we do. Okay. I must have. Right, time to start on questions. Let me see. Color, I will use blue today. So I'm going to work through and kind of explain what I'm doing as I go through the questions. If I get it wrong, please point it out, because as far are there answers? If there are answers, that would be amazing. Yes, there are answers. Okay, so I can check if you do get it wrong. So minus 11x plus 24 is greater than 0. Factorizing right now, you can see how awful I am at factorizing in real life, in real time, and not in an edited video. Two numbers that multiply to make 24 and add to make 11, 6, and 4 is 10. Not that. 12. Yeah, I hate factorizing. Right, I'm going to complete the square to solve this. It's easier. Well, supposedly easier. We're setting it easier to solve this. Okay, time to complete the square. As everyone knows, in my maths class, we all hate, I can't speak, we all hate completing the square. So 120 minus 4 plus 24 is minus 25. Nice to know. Excellent. Letter 2 all squared equals 25 over 4, which is a very nice number actually. 11 minus 11 over 2 equals plus or minus 5 over 2. We square root of both sides. x equals 11 plus 4 minus 5 over 2. This will give me my factorize. Like, obviously, you can do this very much by factorizing, but, 11 plus 5, because I can't do addition, 16 over 2, which is 8. And then 11 minus 5 is 6. 6 divided by 2 is 3. Okay, so we have the main math stuff done. Look, here's our curve that is definitely somewhere over there. This is our very, very accurate curve. That's it there. And 3. And we are looking for y, our function is less than 0. We will shade the bit where the y value is below here, and it is below here from this point and from this point. Oh no, I've got my pen dirty. In there, therefore, in this thing here, x is less than 8, and x is also greater than 3. There's a question done. Problem solved. Maths look awful. It's not too bad. Games GCSE further maths, which is nice. That question could have come up in GCSE further maths. That's not too bad at the minute. By the way, there is a 30-second delay on the live stream because that's just how it works. It means that, like, if I die or something, the stream can be turned off, and also just because it can't obviously go immediately from me to you. Okay, let's do a harder example. 4x squared minus 8x plus 3 less than or equal to 0. Okay. Factorizing. Okay, we have some coefficient of x and then coefficient equal to 0. Solve. We have two numbers that multiply together to get 3. Well, it has to be 1 and 3, doesn't it? And then add to get minus 8 whenever 1 is multiplied by 4 or the root multiplied by 2. 6 plus 2 is 8. So we have 2x and we have 2x. So we're looking for minus 8 minus 6 minus 2 is minus 8. X is a half. And x is 3 over 2. That was much quicker than completing this. Okay. Dishwasher. Right. Very realistic curve. We are half. We are 3, 2. And y is less than or equal to 0. This is another nice one because y is less than 0 at this point, which is from here to here. See in there, x is less than 3 over 2, and x is also less than a half. Problem gelöscht. Those two have been relatively easy. This is going to really be difficult for me factorizing because I hate factorizing. Okay, next question. We have a negative curve. I want to try and find one with a negative curve because, that is useful to know what to do. Any good negative questions? 7 plus 13x minus 2x squared is greater than 0. Factorizing, we're going to get 2x, we're going to get x, and one of them is going to be minus, one of them is going to be plus, but we don't know which is the problem. So, two numbers that add to get 7, or multiply to get 7 and add to get 13, but one of them multiplied by 2. So we have, well, it has to be 1 and 7. So we have 14 minus 1. So it is 2 times 7 and 14 minus 1, which will be minus x times 1. So then, let me just check. So that is minus 2x squared plus 14x minus x plus 7, so that works, I think. And then we have x equals minus 1 over 2, x equals 7, doesn't it? Yes, minus x is So x minus 10. Yes, I am right. Yes, I am. You can tell I'm not good at factorizing. Okay. Now we draw our curve, and let's remember it's an upside down curve. Here's our very accurate curve, minus half and minus 7. There. Minus a half and minus 7. And y is greater than 0. So we're just finding all the points here where y is greater than 0 and it's greater than 0 from this point here and from this point here, shaded here. So x is less than minus half and x is also less than minus 7. Thank you, Lewis. Yeah, it is 7. You see, if it takes me more than 30 seconds to get the answer, I will be able to see your comments, like I can see them all here. But because this takes 30 to 40 seconds to go through, then I don't see your answers until after. But yeah, thank you for sending in answers. I mean, if you want to do the math along with me, that's great. So, what's next? Let's try this one. Minus 2 plus 7x minus 3x squared is less than 0. By the way, I am shocking at factorizing, but in any exam I can use this calculator. It just solves for x for me, which is really nice. Excuse me while I die. Okay, factorizing. We have x and we have 3x setting equals 0 to solve, and one of them is going to be minus, and we're making minus 2 and multiplying, so it's 2 and a 1. And we're making 7, so it's 6. It's 6 plus 1, 7, so 3 times 2 is 6. And, can it be? I'm being really stupid here again, so 3 times 2 is 6. And then 1 is 7. Wait, no, you know what? I'm going to use the calculator because I don't want to spend too much time. We have minus 3x squared, 7x, and 2. Minus 2, not a positive 2. Gives awful answers. So, then we have, I was right, just didn't get the signs right. 1 minus 3x, and then when you get that, minus 3x. Oh no, it's the other way around. Plus 3x equals, oh no! I'm being stupid again, guys. The answers are a third, and you know what? Delete you. In the future, I'm just going to use the calculator because like the minus ones are not developing. So x equals 2 and x also equals 1/3. So yeah, this video I should really retitle it Jude struggles to do basic maths because I can't. So 2 and a third, so the curve, or a very accurate diagram. 2, a third, and then y is less than 0, and in this diagram, y, the y value is less than 0 here, but that is starting at this point going this way, here, and this point going this way, which is here, because the curve is like moving this way after it goes down there. So that's why that is there. Therefore, our answers are x is less than a third. I usually will put a comma, but you can also do, or x is greater than 2. So yes, that's that question done. Right, there are more ones hopefully I didn't file anything away because it'd be so much easier for you to find if you use the book. Teacher said use homework stuff. I want if there's this very specific thing I want to do. Their sketching would be probably useful. There's a specific exercise I want to do. Know that. And the exercise is in here. Let me continue looking. It will be somewhere. Here's a little nice curves, more curves. By some of my maths class, who knows where, you know, like these questions where there were things under. What did it come from? Was it from the textbook or was it from a page we were given? That's all recent stuff. That's all recent stuff. Does anyone know? That would be extremely helpful because I cannot be bothered to go and look it up. But I'll do an example. The one, right, well, I'll do an example from a class, middle grade in class. I don't know like what format it's from. So, let me see. Did I ever get that answer? That is the question, right? It's like exercise 4, 2 over x minus 3 is less than or equal to 1. And so you have to multiply both sides by that squared because it's negative, you have to do the flippy thing, which you're not supposed to do. So 2 upon x minus 3, the one x minus 3 will cancel like that, and the second one will stay less than or equal to x minus 3 squared, which I'll just write as x minus 3. 3x minus 6 is less than or equal to x squared minus 6x plus 9. Keeping that positive because that's nicer. 6 minus 6x minus 2 minus 8x. 9 plus 6 is 15. That's set up to 0 now. Taking everything over. Looking promising. And so if we factorize, and we all know how much I love factorizing, that's greater than or equal to 0. Okay, we have multiplied 15, it's 3 and 5. And it is to get minus 8 minus 3 minus 5, x equals 3, x equals 5. I see, wash your hair. Thanks, Chris. Why or when do you times it by the bottom one squared? Okay. I will quickly finish this question and then I'll come back to that, Zara. I'll just explain it. So we have our positive curve. We have 3 here. And we have 5 here. And so we are looking for whenever our thing is, so y is less than or equal to 0. Y is less than or equal to 0 whenever it's below this point, which is in between. In between here and here, so shading bit. So x is less than or equal to 5, greater than or equal to 3, and you leave it like that. No, it's greater than, or y is greater, sorry, that is wrong. Leaving stupid as per. We're looking for whatever y is. I wrote it down right and just answered it wrong. So y is greater than or equal to 0, and it's greater than 0 above here and above here, which is outside this point here. Sorry about that. So x is less than 3 and x is greater than 5. That's the answer. Okay, so when do you times it by the bottom one squared? So we have, say we had like 6 divided by 2 is less than 10. Obviously 6 divided by 2 is less than 10, but what you would, how to solve that, what you would, well, okay, you can't really solve it, but say it was less than 10 plus x. What you would do is you would, 6 is less than 10 plus x, and you're multiplying it by the 2. 6 is less than 20 plus 2x. 2x is greater than 6 minus 20 minus 14, and then x is greater than minus 7. So that's how that works. However, if, for example, it was, I'm just going to do the same example, 6 over minus 2 is greater than 10 plus x. I mean, obviously it still is, but if we were to multiply the minus 2 up, so it'd be 6 less than minus 2 upon 10 plus x. You can't actually do that because that requires you to flip the sign. So then that becomes greater than, because you're multiplying through by minus 1 as well. And that means that whenever you get your curve, so the curve, say the curve's like this, see it in there. Whenever you multiply through by minus 1, you're flipping the curve. And so it still has to be like in this area, so it goes up into this area, but that means like that is less than 0 there, that's greater than 0 there. So that's what happens. That's actually what happens when you multiply through by minus 1. As you saw, the range in there and the range in there are actually the same. They're just on different sides of the x-axis, but we're just looking at x, we're not looking at the y. So that's fine. Okay, so then we solve that and you get whatever, but the point is, if you bring something up in the bottom, if you multiply through by minus 1 or multiply by minus 2, for example, you have to flip it. So say, I had 6 over x, and that is greater than 10 minus x. We can go 6 is greater than x, 10 minus x, all of x. However, if that x is minus 1, etc., that means we would have to flip the sign to that. But if the x is positive 1, that means you don't flip the sign. And you don't know which one to do because it could be either. So you then square it. So like minus 1 squared equals 1. So anything that is negative on the bottom, if x is negative on the bottom, it becomes positive whenever you square it. So that becomes 6. X squared over x is greater than 10 minus x upon x squared. Then that x on the bottom will cancel out with one of those x's, and then you get that. That is why you do that. Hope that helped. So yeah, those seem fine. Just you can't need to be accurate. We're back. Are we back? Hello? Did that? Okay, we should be back. My Wi-Fi isn't great. Let me just say sorry about that. Okay, so yes, Lara, hopefully you get that. Okay, next. Now let me see. Is that using the discriminant and so I have more questions here that could be using the discriminant. And the range of values, okay, yeah, that definitely, okay, that's using the discriminant. We don't need to do that for our test tomorrow. Let's try one of these then. X upon, using red this time. X upon x plus, I can't even see, is that divided or is that plus? Right, lights are going on. I'll be back in 1 second. And we have new light. Oh, okay, that is awful, isn't it? Let me see. How do I fix this? See if I put my phone torch on, will that solve? Cash and lamp are candy things that learn to come. Okay, right. Do we have flash? Is that a thing? Or are we just going to have to deal with the really awkward thing? Wait, what if I change the light? That's slightly better. Okay, anyway. X plus 11 is less than 3, 1 minus x squared. Okay. X squared plus 11x is less than 3 minus 3x square root of that x, that square root is definitely inside there. Okay. These questions are just so exciting. 4x squared, bring that over to this side, plus 11x, bring this over to this side, minus 3 is less than 0. Okay, so factorizing, as you all know, is my favorite. We have positive x, so I can do that 4, 11, using the calculator because it's faster, and minus 3 gives us 4x minus 1 upon x plus 3, which should set that equals 0. X equals a quarter and x equals minus 3. What does it find the set of values for x? Okay, so then we get our amazing curve, which is very accurate. We have quarter, we have minus 3, and we are looking for whenever y is less than 0. So here, so x is greater than minus 3 and less than 1 over 4. Problem gelöscht. For quadratics, are we told when to factorize or complete the square or use formula? Okay. So if it's like a quadratic, a random quadratic, so like see, and like say it's like some sign here. You know you're not stupid, Zara, don't worry. Okay. Says equal to 0. And it will say you've got a couple of options. Your option may be give answer to 2 decimal places. If it's 2 decimal places, then no, that's not the right one. Then use formula. Remember, formula is not given to you, so you need to remember it. So yeah, so you'll need to remember the formula because it's not given to you. Even if you remember it and write it down as soon as you go into the exam, but it is not given to you anymore. That's gone to GCSE. Number 2, I could say give exact answers. That would signify that you're going to be completing the square. Yes, you're going to be completing the square because you'll get like q plus or minus root r over s or something like that. You'll get that, and that is your full answer there. Oh wow, the stream actually isn't as far behind as I thought it was. Okay, so yes, and then your third option is, it might say by completing the square. It might say by completing the square, or by using the formula, or by factorizing. If it says that, then obviously you do what it says. But yeah, if you use formula equals 2 decimal places, this is exact values. That is how you really know which one to use. Okay, I feel like that is quadratic inequalities like sufficiently revised. If you want any more, let me see if there are any more. There's some wordy questions, but you kind of just get that from context. Okay, so I want to do surds for myself. Let's have a maths, except there's no pen, no paper equation. Oh, okay. So wow. Anyway, okay, you have to know how to do like just basic inequalities on number lines, or double inequalities on number lines. So that's like the question, minus 1 is less than 2x plus 1, which is less than 11. So you separate it into two things, so it's minus 1 is less than 2x plus 1. 2x is, bring them at plus 1 over and minus 1, so minus 2. X is less than minus 2. Am I right? 2x plus 1, bring it over. No, I'm not, that's minus 1. And then on this side we have 2x plus 1 is less than 11. 2x is less than 10. X is less than 5. And then on your number line, so we should say just like that. This is your number line. X is greater than minus 1. So always label 0. I don't know why. There's minus 1. And here is 5. Doesn't have to be very accurate. And then, so there's your number line. And then what you're doing is it is less than. So what you have is your circle at 1. Have a circle at 5. X. So whenever you've got like x and then you've got a less than on one side, you've got like the same sign on both sides of x. So yeah, it means it is between basically. And because it's less than and not equal to, you have open circles, which means it starts where it doesn't start there, it stops like cross. Look, Denison, hey, can you help me with this question? If you tell me what the question is, then yes, I can try. Can't guarantee you, but I can try. So send me the question on YouTube, preferably, not on Instagram, because I'm using my phone to live stream and can't not use Instagram at the same time. So yes, look, Denison, if you... Oh, the question is, who is Joe? Joe Mama? Question mark. Or is it Barack Obama's first name? Those are the questions we ask ourselves every single day. Next. Let's try another one. This question is... Yes. Anyway, 4 is less than or equal to 7x negative I, which is less than or equal to, yet again, 11, everyone's favorite number. So separate it. We get 4 is less than or equal to 7x negative I. Bring that over and you get 7 is less than or equal to 7x. X is less than or equal to 1. And then 7x negative I is less than or equal to 11. 7x is less than or equal to 11 plus 3 is 14. X is less than or equal to 2. And x is in the middle, so we have our number line. We have 0. We have 1. We have 2. They're all pretty close together this time. Technically, should be further apart just for reasons. We have our two circles. They're connected. And it is less than or equal to, so we shade the circles in. That's visual representation. Kind of like shading in our graph. Obviously, you can get ones where it extends off into infinity in either direction, but not if it's double one like that, and they're not too hard to work out. Okay, that's no more quadratics. Let me see. Curve sketching. That is a thing on the test. Let me see, where is the curve sketching one? They're not using the discriminant because that's fun. Solving quadratics. Where are sketching quadratics in the book? Sketching curves. Cubics? Nope. Plotting graphs, quadratics, solving quadratics, sketching graphs of quadratics, page 23. Page 23. Here it is. Okay. Sketch the graphs. That's nice. What is, okay, Joseph, this may or may not, I don't know, I can't say it. Anyway, let's change color. Oh, I have 20 books, that's nice. Okay, let me change color because I'm getting bored of those. Okay, yes, okay. Hi, Joseph. Sorry, maths group chat's going insane. Okay. Anyway, sketch curves. Okay. Y equals 6x squared minus 19x plus 10. Then we're going to factorize, my favorite part. Actually, technically whenever you're sketching curves you have to work out maximum and minimum turning points and things like that, so let's do that now. Okay, so we're going to solve this by completing the square to get our maximum and minimum points, because that's how you do it. So completing the square, you get, actually what you're going to want to do is divide it through by 6 first to get x squared by itself. So x squared minus, that's 19, that's an awful number, 19 over 6x plus 10 over 6, x squared minus 19 over 12 squared minus, who knows what 19 squared is. That is not one I've learned off the top of my head. 361 is the answer, over 144, plus 10 over 6 equals 0 in this context. Okay, minus 361 over 144 plus 10 over 6 is minus 121 over 144. How very nice. Okay, x squared minus 19 over 12. That's actually very nice. Minus 121. 144 is 0. Why did I go to over 12 instead of over 6? Because whenever you're doing this bit here, yeah, you get it. Yeah, you have to divide it by 2, so 19 over 6. Divided by 2 is just putting it over 2. So 19 over 6 times 2, yeah, okay. For people who didn't get it, sorry. 19 over 12 all squared equals 121 over 144. Right, I'm going to start rubbing out the stuff before here, because I don't have enough room. This should also get the steps are going. Then we get x squared minus 19 over 12 equals 11 over 12, and we square root it, so plus or minus. And then let's go back up here. X squared equals 19 plus or minus 11 12, and now we could type it in. 19 plus 11, you know what, 19 plus 11 over 12, and you get 5 over 2. That's not squared, sorry. X equals 5 over 2, and x is also equal to, whenever we put the minus in, x also equals to 3. Now let me just check if I did this. Well, give me the same thing. 6 minus 19, 10, 5 over 2 and 2 over 3. Nice! Oh, hi Amelia. Are you joining for some help with your maths that is not in any way relevant to this? Or just for the crack? Because I mean, why not? I'm the best brother you could ever wish for. What? Anyway, so we have our two values of x. I completely forgot to do the whole point of this, but anyway, those are our two x values for whenever we're crossing. Now, I get that so easily. Okay. We need our max or minimum point. It's a positive curve, so let's do that is a min x value, so our minimum x value is, or sorry, not minimum x. Wow, I am tired. Minimum y value, because that is on this axis. Then y is whenever the bracket equals 0. So we have, in a bracket, we have x squared. Ignore everything I do. Oh. That's better. Ignore the fact that I did that entire thing wrong. I'll do another one of these. I feel like Amelia is standing outside my door right now. Amelia.
Hello.
Amelia, can you? So I am currently.
I am watching.
Okay. Can you let me work?
Okay.
I would very much appreciate that.
Okay.
Zara, kid, says hi, Amelia. You know Zara? The ginger one. That's not Sarah Smith. Who was at break time today?
I like her.
That's Zara. Amelia says she likes you. Okay. That is our bracket here. That needs to equal 0, so it's just the opposite of that. So our minimum y is 19 over 12, which is beautiful. Zara says she likes you too. And then this happens whenever. Am I right? No. Right, guys, I am dying. Amelia, would you leave so I can concentrate because I'm getting this completely wrong.
Okay, bye.
Our minimum y is whenever the bracket equals 0. And whenever the bracket equals 0, x equals 19 over 12, and the minimum y is this bit here, which is minus 121 over 144. Yeah, so this kind of this is my descent into madness, in case you haven't realized. So okay, so that is our minimum y value. So now we go to sketch the curve. I'm going to rub all this out. Yeah, we're definitely doing another one of these because it's not going well for me. Okay, let's attempt. We draw our positive curve. You can literally draw a curve like that. Then you have this point here is the x value is 19 over 12. So draw this. Here we have 19 over 12. Our x values are 5 over 2. Which one's bigger, 5 over 2 over 2 or 3? 5 over 2 is obviously bigger. 5 over 2, and then here is 2 over 3. Yeah, comment if you're loving my descent into madness, because you know what, I'm not. Okay. Yes, and then our y value, so our y-axis, this curve isn't wide enough. You go off into infinity there, and you can go off into infinity there. Our y-axis, or the y thing, yeah, Zara, same, honestly, I'm just too tired to even concentrate. Your mine's 121 over 44. And then up here is our intercept, which is that. So that is 10, and that's how you sketch a curve. That answer's right. It's just my working out was a tip. Okay, let's do another one if you feel like doing it with me to make sure I'm not doing anything wrong. If you see me doing something completely wrong while completing the square, scream at me in the chat. All caps would very much help. There's 6 of you here, and I'm sure at least 2 of you do maths. Zara, definitely you. So if you see me do something completely wrong, just like scream at me, please. Okay, let's do another positive one so I will be able to do it, and then we'll try a negative one. Here's our thing. We're going to solve by completing the square because that's how we can get our maximum and minimum points. Dividing by 3 gives x squared minus 2/3 x minus 5 over 3 2/3 x is actually the same as 2x over 3. I just like writing it that way. Equals 0. We're going to put into our brackets. So you divide this one by 2. 2 over 6x. Nope, sorry, that x is not there. I always do that. The x here is just that term. That is squared. We are taking out that squared, so that's 4 over 36, and we're also taking away 5 over 3. So that's nice because obviously it's going to be positive when you bring it over, so 4 over 36, and so what? Yes, as you can see, that is a 36 in the base on the bottom line. The denominator is 36, and then minus 5 over 3. You can tell how tired I am by the quality of my maths work. Minus 16 over 9. X minus 2 6. No, 2 6. I know is a third, but we're going to leave it like that for now. Equals 0. X minus. Actually, we know we'll convert it to a third. You don't have to, but 16 over 9, but I realized that whenever we got to this point, it would be worthwhile. So x minus a third, so we're square rooting this side, we have to square root this side, plus or minus 4 over 3, that's 3 on each piece. Okay, then x is equal to 1 plus or minus 4 over 3, which makes our x equal to 5 over 3. And x is equal to 1 minus 4 is minus 3 over 3, which is minus 1. Now let me use my calculator to check. This is kind of how you're supposed to do it. Or use the calculator. So we have 3x squared minus 2x minus 5 over 3 and minus 1 would be, I can complete the square. So we have our 2x values. Now we need, now you can see the 2x values. It's not just me rambling on. Hi, 4 people viewing. There are currently 4 people viewing. We know, by the way, believe it or not, we had 11 people. We had 10 at once. That's our maximum, I think. I have a curve on my thing. Will he allow us to use our calculator to do that tomorrow? Yes, it is calculator paper. He can't not let us use them because it's just a calculator. So, I mean, if it's part of the calculator, you're allowed to use it in the exam. So, well, I mean, that's my logic. You better allow us to use our calculator to do that tomorrow. Okay, so now, because our curve is a positive 1, this is our minimum y value. Whenever x plus the thing in the bracket equals 0, that's just like something random. Okay, so our minimum y, whenever this is 0, that's just like not there. So our minimum y value is min y equals minus 16 over 9, and this is whenever x is equal to thing in the bracket, so a third. Very nice. We also know our intercept is here. So sometimes I do draw out the axes. Very rarely do I. Here we have minus 1, because the curve doesn't ever look as nice. Here is 5. 5 thirds is 1 and 2, 1 and 2 thirds, so 1 and 2 thirds, we'll say that's there. Our minimum y is minus 16 over 9, and x is 1/3 here, and then our intercept is minus 5. Minus 16 over 9, that is going to be greater than 5. It's minus 5, isn't it? Minus 16 over 9 is minus 1, so here we have minus 5. So, are you ready for the horror that this curve is going to be? Well, hey, it looks like a cubic. So sometimes what I'll do is I'll have drawn out this bad curve, and then what I will do is I will like draw out a good one, and then draw in the axes. So we know that that is there, we know that this is here, and then we know all the values. So that's 5 thirds. It makes it look like you're an amazing curve sketcher. We know that this point here has to be minus 5, and we know that this point here has to, so you know, you can do that. Just make sure a big diagram and what color? Red and orange. Okay. These colors represent the fire in my heart, as I hate these. The red represents anger. Sorry, that's a Die Hard reference. Anyway. Okay. Negative curve. Okay. Here we go. Y equals minus x squared plus 6x plus 7. Ah, you're wearing your onesie. Yes, I am, Amelia, believe it or not. I didn't care how to spell it. Well, you're close. It's just mess. Right, to complete the square, what we're going to do, we're going to take an x outside, big brackets, x squared minus 6x minus 7. Okay, and then we're going to complete the square. So we have x minus 3 all squared minus 9 minus 7. So minus 9 minus 7, I should know that is minus 16. X minus 3 all squared. Minus 9 minus 7 is minus 16. We are in big square brackets. Minus, oh sorry, this equals 0. Because we're solving it. It equals 0. How long has this been on for? Just under an hour for me. I had to do a wee test before. It's been an hour for me, but it's been on for some time. This is called revision, Amelia. You'll learn about it whenever you have exams, which are reasonably soon. Okay. Anyway, now what we're going to do is we're going to multiply through by the minus x minus 3 squared. So minus becomes plus 16 equals 0. Wow, now we have a positive. So our minimum y value is this one here. So it's 16. Sorry, it's not a minimum y because it is actually a maximum y because our curve is like this. So our max y is 16 whenever x. Now, remember this minus sign isn't going to affect the inside of the bracket because we just want the inside of the bracket to equal 0. So this minus sign doesn't affect it, which is very nice for this question, obviously. So, yes, whenever x equals 3. So that's our turning point. And then we solve this, so minus x minus 3 squared equals minus 16. Now what we're going to do is multiply through by minus 1 again. X minus 3 all squared equals 16. Because obviously you can't take, well, that's just for people's information. If you were to take the square root of that, you get 4i. But that's not the point of this live stream. This is an ordinary maths one. You will see me truly raging if I do further maths on one of these studies on these. I do have to go at 8 o'clock because there's half an hour left. Algebraic fractions, maybe they're not really that difficult. So yes, after this question, or like while I'm doing this, send in requests for stuff that you think I should cover next, because I don't even know. X minus 3 equals plus or minus 4. X equals 3 plus or minus. What should I do next? Interactive content, woohoo! There's one person watching. Hi. It's not loading. Well, it says the connection's fine. Did we go over the time? Is this got other people are watching again? Hello, what next? If it's lagging again, sorry then, Amelia's using the internet. Sorry, Amelia. Yeah, what next? I have half an hour. I have something under surds like a plus b root c. Oh, okay, right. Surds. So, a plus b root c. So basically what that is if you have a surd, you can have, that's an answer in surd form. This is also an answer in surd form. So that would be like 2 plus 5 root 7. So basically if it says give your answer in the form a plus b root c, you have your a there, that's your b, and then that's your c there. That's what a plus b root c means. So yeah. Okay, I might do some sort of questions if I can find some nice ones or horrible ones. Let me see. Surds, your quadratics, algebraic fractions, factorizing fractions, surds. Okay. What is the question? The question is 4 over root 8 plus 6 over root 2, and you just have to simplify. So, Yeah, you just have to simplify it. That's all you have to do. Let me see. Can't remember how to do it, so obviously you're going to want to rationalise the denominator in both of them. Or, by the way, root 8 is 2 root 2. So then we're multiplying this by 2 root 2 over 2 root 2. Am I right in saying that? Or I suppose you can multiply it by root 8 over 8. But root 8 is equal to 2 root 2. And then we're adding 6 over root 2 multiplied by root 2 over 2, root 2 over root 2, because that is basically root 2, like that is equal to 1. So you're not actually changing the number, but you're taking away this. So 4 times root 2 over 2 is 8 root 2 over 2 root 2 times 2 root 2 is 2 times 2 times root 2 times root 2, which is 2 times 2 times 2, which is 8. Isn't it? Am I completely wrong in that? Probably. 2 root 2 times 2 root 2 is 8. No, I was right. Okay. And so that obviously cancels. Gives you root 2 plus 6 root 2 over 2 with 2 cancels. 6 cancels to give you 3, so we have root 2, the 8 is gone, plus 3 root 2. Root 2, if I say root 2 is x, it just means you get 4 root 2. There we have our answer. That one was easy enough. Yeah, don't panic about thirds. I will, but don't panic. Let's see, do we have a hard one? Okay, root 2 plus 2 root 5 over 2 root 5 minus root 2. Okay, we have two third terms and one minuses. This is non-GCSE maths. This is new to A level. Well, not as new for us on A level. So 2 root 5. We need to rationalise the denominator, but whenever it's minus or plus, you have to flip the sign. So then we multiply like brackets. So root 2 is 2. That is the same as this. Two root 5. Nope, you're wrong. Minus root 2. 2 root 5 plus root 2. Okay, that was a mess, but anyway. Root 2 times 2 root 5 is 2 root 10, because 2 times 5 is 10. Because you can do that for roots. And then we are adding root 2 times root 2, which is 2. 2 root 5 times 2 root 5 is 4. 2 times 2 times 5, which is 4 times 5, which is 20. Or no more. Can I do that? I'm multiplying it, and then we have 2 root 5 times root 2, which is another 2 root 10. So that is the top line. Bottom line is 2 root 5 times 2 root 5, which is 20. And then we have a 2 root 5 times plus root 2 and a 2 root 5 times minus root 2. They will cancel, just because you add and subtract. So whenever there's cancel out, you don't have anything, and then it's minus root 2 plus root 2, which is minus 2. So then this equals 4 root 10 plus 22 all over 15, and you can simplify that, because you always have to simplify, that's like the main point. 2 root 10 plus 11 all over 9. Now, if I went to my calculator and typed in root 2 plus 2 root 5, and I'm putting brackets around this just so that it's all one term, divided by 2 root 5 minus root 2, what do you get? 11 plus 2 root 10 over 9. So yes, the calculator gives it in A plus B or C. You can obviously, that doesn't matter which way those go round, but calculator wants 11 plus 2 root 10 over 9. They're the same thing. Or you can also write that as 11 over 9 plus 2 root 10 over 9. It's all the same thing. Okay. Unless there's anything else anyone wants to do, that was on the test. I think I'll do one more question and then I'm going to go because I'm tired. Let's see. Okay, here's a question. We have a box that is definitely a rectangle. Points are A, B, C, D. What width starting at the left corner, top left. And then this length is 3 root 7. This length is root 21. And the question is, what is the perimeter of this? And what is the area? And what is the diagonal? So, perimeter is 2 times root 21 plus 2 times 3 root 7. And you get 2 root 21 plus 6 root 7 root. So just check root 21, does that cancel down? No, it doesn't. So that is just the perimeter. Simple as that. Yeah, okay. So perimeter. Now we have area. Area is length times breadth. So we have root 21 multiplied by 3 root 27. No, 7. Yeah, 7. So that is equal to 3. 7 times 21. Equals now. I don't know the discriminant. Oscar, that's not in our test tomorrow. I will do something about the discriminant once I understand it myself. Root 7 times 21 is 7 root 3. So that's obviously 49 times 3. Yeah, 147. So 3, 7 times 7 times 3 equals 3 times 7 is 21 root 3. So let me just see. We have root 21 multiplied by 3 root 7. I hope this is right. 21 root 3. Okay, so we've worked at the perimeter, we've worked at the area. Now for the diagonal. This is Pythagoras Theorem. A squared plus B squared plus C squared. A squared is the diagonal length. So the diagonal length is equal to it is equal to 3 root 7 squared. So times 3 root 7 plus root 21 times root 21. X squared equals 3 root 7 times 3 root 7, which is 9 times 7 is 63. Am I right? 9 times 7, 63? Mm-hmm. Yes. And then we have okay, curve sketching with inequalities. Oscar, that I did that earlier in the live stream, so if you want to like scroll back at the end, that has been done. And I can't be bothered to do it again because that took up so much of my time. Sorry. And that's just 21 there. 63 plus 21 is 94. No, sorry, 84. And then A is obviously the square root of 84. And of course it's a length, so technically it's plus or minus root 24. But it's a length, which is always positive, so that just means it's always positive. So area for 84 modulus by root 84. Root 84 is equal to 2 root 21. And that is our diagonal length. So that is like a worked example of a slightly worded question. I am tired. I am extremely tired. So I'm gonna go now. Thank you for watching. Study well for our maths test tomorrow if that's where you're from, or whatever other revision you're doing. during this. So yeah, thank you all for watching, and we'll see you all in the next video, which is out on Friday. In case you want to hint at whatever video is coming out on Friday, because I mean, who wouldn't? Where is it? I wonder if I've even uploaded the video. That would be just like me not to have uploaded it. Let me just scribble this out because I'm not leaving just yet. Studio YouTube. Friday. Yeah, Oscar. Next Friday's video is. Let me see if I can find it. Videos. The one coming out on Friday. Right, this has been like. What day is tomorrow? Oh, Friday the 4th. Okay, no one's going to watch this. It's about the language I've been making up myself. So yeah, no one's going to watch that. It's not a school video in the slightest. No one's going to watch it. That's awful. Whoops. But yes, we're a bit blurry. Hello. Unblur yourself, please. Are we just going to be blurry? Okay, that's fine. So yeah, next Friday's video, my language. You know what? Please just watch it. It's called Electron. I've been making it for quite a while. Okay, yeah, so bye. This is me actually going this time. If anyone is still here to find out. There were 5 people here, so goodbye 5 people. And now I'm Mila. Mila is actually in the room with me at the minute. That's her hand. Okay. Bye. It's just me having fun. Okay, I'm leaving now. Bye.